Hello everyone. If you can hear me, can you just let me know in the chat first? Just to make sure that our audio is fine. Okay, so hello everyone, and welcome to our review of the SMO Junior from this morning actually. And the SMO Junior was 2.5 hours long, so this session is also going to take around 2.5 hours. However, this is not the SMO anymore, so please feel free to move around, use the washroom, have a snack. Even if you're having your dinner right now, that's okay. And along the way, we probably will squeeze in a couple of breaks so that my voice can get a break and your brain can also have a break. Now, our plan is very simple. We hope to go through all the 25 questions in order. And of course, if you need to leave early, you can watch it back later. It will still remain up on YouTube. And if you realize that maybe the first few questions, I don't need to hear all of this, I have something to do first, that's also fine. Now, just a couple of important guidelines for our chat. Currently, we have about 40 plus people in here, and I'm not sure how many more will be joining in the coming moments. Right? But we just want to make sure that this is a conducive environment. So firstly, if there's any issues with the video or with your ability to hear me clearly, please let me know. And if I do make some serious mistake, meaning not just a grammatical error, but something where I have mathematically been seriously wrong, please let me know, and let me know in the chat also means that everyone else will be informed. This can happen after 2.5 hours of talking. At some point, I'm probably going to say something really silly. Now, do also clarify any doubts. For example, if you do not understand how a certain theorem works, you don't understand a particular step I did. Now, I won't be able to answer everything that is asked. However, if many people do not understand something that I did say, then I should probably be able to take a bit of time to address them more directly. Also, one more thing is that this is just my solutions, and I'm quite certain that many of you would have done it in a different way. So if you have a method that is much faster, much better, and you think that, hey, this is going too long, I think I have a faster approach that I did this morning, then do let me know. Now, please do not spam, and I know that we have a tendency to compare scores. Oh, I got 22, I got 15, oh no, I only got 2. Now, whatever it is, please two things. One, do not spam the chat with what score do you get, what score do you get, and what score do I need to get a bronze, what score do I need to get a silver, what score do I need to get into the top 10. That will confuse everybody when we are trying to deal with numbers as the answer to questions and you think that the numbers are the cutoff score. So let's not go there. And during the breaks, perhaps I'll loosen a bit on the chat. You guys can talk about how you felt. Was it easy or difficult? However, please be tactful. Don't say everything's trivial and why are you so stupid or something like that. Okay, please be respectful of one another. Now, the plan is not to go through every single question step by step to the degree of showing how you did multiplication, showing how you use Pythagoras Theorem. I'll just give the key insights and then the main steps to get the problem, but not every single nitty-gritty detail. So if there's any theorem that I think not many of you would have seen, or any technique that is generally less well known at the SMO junior level, I will probably mention it for a while. But if it's something that I think should be mostly well known, let's say how to solve a linear equation, or let's say similar triangles, I'm not going to elaborate on those too much. I'm just going to say these are similar. Now, something that as math teachers we like to say is that it's not just about the final answer, it's not just about what you scored, but in this case, it's really true. Now, when I was doing the SMO, I know that my experience was that I wanted to know what I scored. I wanted to know how many I got correct. So what happens is that when the SMO takes place, and let's say that I managed to solve 15 questions, let's say. Now probably when I know how to solve 15 questions, and then after the SMO, there'll be one question I'm curious about, and then I'll ask my friend, how do you do that? And then he explains it, and now I know how to solve 16 questions, and everything else in the SMO, I still don't know how to solve it 3 months later. Now that's not ideal. It's not ideal to spend all your time preparing for the SMO, solve some questions, and never ever figure out how to solve the rest. So even for those that you did correctly, please just pay attention to the approaches, and maybe you will see that, oh, there was a faster way that I didn't think about. And if you didn't solve a question, even if it was completely lost, or if you got halfway there, think about why you didn't manage to figure it out. And that's really the reason why we are doing this on the same day as the SMO. You definitely remember which questions you got stuck on. You definitely remember the one that gave you a fright. And you definitely remember the one that you thought was super easy, but then your answer turned out different from the suggested one. So take note of any patterns, theorems, important ideas that you missed out, and then we will hopefully be able to do better the next time. Now a quick word about me, because you're going to see my face in the corner for about 2 over hours more. So as you know, my name is Wei Tan, and a very abridged and somewhat incomplete educational history. I was from NUS High, graduated from NUS High in 2014, and I actually just graduated from NUS with double honours in math and computer science. Now, if there by any chance are any of my teachers from my time in NUS High or my time in the national team, hello, nice to see you, even though I think you're only seeing my face and not the other way around. And you probably know that this is not the complete story, but I think that's not really what you're here for. So I did take part in the SMO. I was in this same position as you guys not that many years ago. And I was circulating around the national team, but I didn't get into the IMO team. I'm very open about this. And the reason why I say that is at least one contributing factor why I didn't quite make the IMO team was that I stopped learning new stuff. So as you can see, I did place well in the SMO Junior and I placed well in the SMO Senior. Now in order for me to climb from there into the IMO team, there were more things that I needed to learn. But instead of learning those things, I just did more questions. I did more practice, and then maybe I solved 70% of the questions I practiced, and I didn't always learn from the other 30%, which is really where we can grow from. And so I hope that for those of you guys, maybe there are some of you who are also in this same position, you are in the junior team or hoping to get there, you solve 20 questions, well, learn from the rest of the questions you didn't solve, rather than just focusing on those that you did. Now, a couple of quick acknowledgements and disclaimers. You can see right at the top of your screen, there is the Singapore Math Society logo. Now, the reason why the logo is there is because the SMO, of course, is organized by the Singapore Math Society. However, I have to clarify that this is not an official SMS event. So if I make any mistakes here, or if you look at my solution and say, why is the solution seem to use something that is not in Sec 1 and Sec 2 syllabus? It is possible that maybe the problem setters had a different solution in mind. So please do not take these as the official solutions, even though I am fairly certain my solutions are one possible approach to solving the question. Now I have to also acknowledge Math Hub, which is where I'm actually currently teaching and where I am currently physically located. So this is not an official event of Math Hub either, but thanks to them for giving me the time to do this in my working hours, and also for a room some audio equipment and some publicity, which was very helpful. Right? And also thanks to Lim Lee and family for helping to publicize this session on their blog. Now, we have got 60 over people in now, which is, I think, a decent enough number where I think we will get straight into the problems. And for anyone else that will come in later, I will just remind that they can look at the playback later or just watch the clip once the stream is over. Right, and without further ado, we shall get straight into the problems. Now, I guess you can see this is obviously a scanned copy, and this was not a set of questions that I had access to in advance. So in this afternoon, as many of you were trying to figure out what are the answers to these questions, I was looking at the questions and also trying to figure out what are the answers to these questions. And so this is more or less the approach that I took when I'm looking at all these questions. And that means that it is the closest thing to a live solve, as you can expect. Now, the only thing is that it can't really be live because I did need to prepare the streaming setup and all these questions here, so I would obviously have seen them a bit earlier. Nonetheless, this is pretty close to how I would do it if I were a student, and maybe some of you can take a couple of pointers along the way. Alright, starting with question 1. Let A and B be real numbers such that A is negative and B is positive. Which of the following is not true? Now, in any SMO problem, and this is something that experienced participants would know, there can only be one correct answer. So if you encounter these kinds of problems, you're most welcome to just substitute some values in. Sorry, I think there was a brief break, so sorry for that, and hopefully the audio is back up and the video as well. Okay, so let's get back to the problems. Sorry about the technical issue. So as I was saying, the fast method for such a problem would be just to try something like A is -1 and B is 1. We just try these values and we see what happens. Now, it is only one of them that is going to be not true, so you would expect 4 of them to be correct, and so the first statement becomes 1 is greater than 0. The second statement becomes -1 is less than 0. The third statement becomes -1 is greater than 0, which is wrong. And at this point, you already know that option C is correct. Correct meaning that it's not true. Now, at the same time, if you wanted to solve this properly, all of these inequalities can be dealt with in general for A and B. So C is the correct answer, but let's look at the general case. For A squared B, A squared will be positive and B would be negative. So B would be positive, so therefore the product will be positive. For AB squared, A is negative and B squared is positive, and so the product is negative. For A over B, A is negative, B is positive, so the overall is negative, and that already tells you that C is wrong. For D, b minus a. b is positive and a is negative. And so the difference of a positive minus a negative number will be positive. And finally for e, a minus b is negative, but once you take the absolute value of that, it becomes positive. And so therefore we can see that only C is incorrect. Right, so hopefully you have gotten the technical shenanigans out of the way, and the rest of this will be as smooth as possible. Now, another thing that I have to emphasize, some of you here are used to maybe a lesson where you have time to copy down. This is not really meant to be a lesson where you copy down notes. I'm just going through the ideas, so try to pay attention to the things that I mentioned verbally. Don't worry about copying down. This will be made up on YouTube, so if anyone of you says that, hey, I want to copy down that solution to question 11 or something like that, you can always do that later. Question 2. This is a balance, and as usual, it tips down to the heavier side. I think we had a very similar problem to this last year. So if we look at the left balance, it tells us that the square is lighter than the triangle. If we were to look at the right balance, it tells us that two squares are in total lighter than a circle. So of course that means that the square is already the lightest one. Now, how do we compare the triangle and the circle? Well, we can look at the overall balance. And the overall balance tells you that the circle, triangle, and square are lighter than the right side, which is a circle, and 3 squares. If we cancel off those that are in common, which is a circle and a square, then we see that the triangle is lighter than 2 squares. And so if the triangle is lighter than 2 squares, while 2 squares are lighter than a circle, these two put together tell you that the triangle is lighter than the circle. And so the correct answer is option B. Now, next up is question 3. You have got x, y, and z, which are some exponential expressions, and you're supposed to put them in order. Whenever we have such problems, we always want to look, okay, so what's the gimmick here? Is the gimmick that the bases should become the same, or that the exponents should be the same? Now you notice that the exponents are 20, there's a 5, and then there's a 10. So all of these are multiples of 5. Which is really convenient. So because all of these are multiples of 5, we can write them each as fifth powers. When we write them each as fifth powers, meaning that we write it as something to the power of 5, 2 to the 20 times 3 to the power of 5 would be 2 to the power of 4 times 3, and then the whole thing to the power of 5. Y would be 2 times 5 squared, and then the whole thing to the power of 5, while z is 7 squared, and the whole thing to the power of 5. So all we need to do is calculate what's inside. 2 to the power of 4 times 3 is 48. 2 times 5 squared is 50. And 7 squared is 49. So it looks like the problem setters were quite deliberate here, that they wanted the numbers to be pretty close together and you wouldn't have any alternative method apart from this. So y is greater than z is greater than x, and that's option C. I think by usual SMO junior standards, the first 3 questions here are kind of the warm-up, meaning that quite familiar, and then 4 and 5 are the more difficult multiple choice questions. I think in recent years, the MCQs were usually easy except for the last one, so maybe this was an exception where 4 and 5 might have been a bit more tricky for those of you who are less familiar with such constructions. In question 4, 6 circles are tangent to each other, so they're touching at a point. If the radius of the largest circle is 1, and the radii of the 4 medium-sized circles are equal, essentially the other 4 circles are the same size, what is the radius of the smallest circle? Now, when you encounter such problems, what you need to do is to try to look at this figure and find some condition. You need to look for something that it is telling you. What exactly does this bunch of circles tell me, and how do I go about making use of the fact that they're touching one another? Right? Because the fact that they're tangent to one another is the most important and frankly the only piece of information you really have. Now let's highlight the points of tangency, the places where they touch. So you have a lot of nice symmetry going on here, and you just want to figure out, how do I make use of the symmetry and how do I make use of the fact that they're touching? Well, to make use of the fact that they're touching, you can draw a line through their radii, and you know that it will definitely go through this point of tangency. Now I'll do the same to the smaller circle. And what can we say about this triangle? Well, since our figure is symmetric, this must be 90 degrees. And furthermore, because it's symmetric, it means that this is an isosceles triangle, which is 45 degrees and 45 degrees. Now let's call the radius of the small circle and the big circle x and y. So, see the small radius, I'm going to call it x, and the medium radius, I'll call it y. Based on what I've just drawn, the two shorter sides are x plus y, and the longer side is 2y. Now in any 90, 45, 45 triangle, the ratio is 1:1 is to square root 2. Just simply by Pythagoras Theorem that your lengths are in this ratio. So what it tells me is that the hypotenuse 2y is square root of 2 times of x plus y. If you divide square root 2 over, you get square root 2y equals x plus y, and that means that square root 2 minus 1 times y equals to x. So that's one equation. Now what other information have we not used? Well, We haven't used the fact that the radius of the large circle is 1. So we haven't used the fact that the radius is 1, and the radius of the large circle is 1 is also related to x and y. Because if we extend it all the way up to here, this would be another y. So x plus 2y is equal to 1. Now these two equations together, we know that we should be able to solve for x and y. So let's do the substitution. If we substitute x into the equation and simplify, after substitution, square root 2 minus 1y plus 2y. So square root 2 plus 1y equals to 1. And y equals to 1 over square root 2 plus 1. And so x, which is what you want, is equals to square root 2 minus 1 times this. But hey, that doesn't look like any of our options. So what do? Well, if you see this, maybe you're tempted to say, oh, it's none of the above. But that's not quite right, because when we have such expressions, we have to rationalize the denominator. And to rationalize it, we use the conjugate. So the conjugate of square root 2 plus 1, you can use 1 minus square root 2, but for convenience, I'm going to use square root 2 minus 1 as well. The reason why we do this is that the sum times the difference of squares, it will simplify. So the denominator becomes just 2 minus 1, which is 1. And we're left with what's on top, which is square root 2 minus 1 squared. Square root 2 minus 1 squared, if you expand it, would be 3 minus 2 root 2. Which is one of our options. It is option B. Yes, I think this is one of the more challenging questions, not just for the geometry, but because you have to deal with the certs with square root 2 here and there. And if you don't do it correctly, you may end up just thinking it's none of the above, which isn't quite right. Alright, let's move to the last multiple choice question. And conveniently enough, this uses the exact same thing as we just talked about in question 4. And this is really on the nose because square root 2 plus 1 showed up again, which we just saw about 20 seconds ago. It showed up in the denominator, and we just saw how we can simplify it by multiplying with the conjugate. So you can do the same thing over here for each of these fractions. So let's write it down again for completeness sake. You multiply the top and bottom by square root 2 minus 1. And then the difference of squares would be 2 minus 1, which is 1. Now if we just repeat that for one more example, then you get the same result. Root 3 minus root 2 is on top. And the key is that the two things that are being square rooted always have a difference of 1. So in the same way, this becomes square root of 3 minus the square root of 2. So if we continue down this route, the last fraction would also have a similar result. So I'm not going to show the steps this time, I'm just going to state what's the last fraction simplifying to. And this is root 2021 minus the root of 2020. So if you add up everything that I've written in this right column, if you add up all the things in this right column, so let's just put a couple more in just to make it very clear. I'll just write root 4 minus root 3 should be the next one. And then root 5 minus root 4, and so on. Then you're going to get a very nice telescoping series where a bunch of stuff cancels out when you add them together. With the exception of the first and last one, which is square root 2021 minus 1. Now it's going to come in pretty handy in a short while to know that 2021 is pretty close to 45 squared, which is 2025. So this is slightly less than 45 minus 1, which is 44, and that means that the closest that you can round it to is 40. Yeah, so that takes us to the end of the multiple choice section. I guess I will target to get to maybe question 10 and then we'll take a short break. Because questions 6 through 10 are still okay. I think the real headache starts after that. So we can go through from 6 to 10 and then we'll take our break. So I see in the chat some of you checking some things on scores as I mentioned at the start. We want to talk about scores now while I'm going through the questions. What you can ask though is if there are any of these problems that you don't understand my explanation, or you think that you have a better method or a also just as good method that you want to share, then by all means please do go ahead. Okay, question 6. X is a positive integer. The LCM of x and 14 is 42. And then the LCM of x and 33 is 66. Now once again, I think this is one of the questions which is pretty guessable. Because you know what LCM is. So LCM tells you that x is a factor of the LCM. The lowest common multiple of x and 14 is 42, also means that x is a factor of 42. So x divides 42. This vertical line just means is a factor of. Similarly, x also divides 66. And collectively, that means x is a common factor of 42 and 66. So if x is a common factor of 42 and 66, that means that it is also a factor of the HCF. And I think the HCF of 42 and 66 is pretty easy to calculate. It's just 6. So since the HCF of 42 and 66 is 6, x is a factor of 6, you certainly can try the different values. And you would see that, well, x equals to 6 does work. We also can say that x equals to 2 and 3 don't work, because for the first statement, in order for you to require 42, that means that x must have provided a factor of 3. And in order for the second one, for the LCM to be even, x must be even. So put together, it also tells you that x must have the factors of 2 and 3. So 6 is the only possible answer. As I said though, this is fairly guessable since there are not many common factors of 42 and 66. So I don't think this one would have posed that much trouble. Okay, question 7. What are the last 4 digits of this sum? 1 plus 22 plus 333 plus 4444 until 99999. I'll give your answer as a 4-digit number. Well, last 4 digits of this sum means that we only need to focus on the last 4 digits of this bunch of things that we are adding up. And so what we need to do is to just isolate 1, 22, and 333 are as they are. And everything else at the back would be written as 4444, 5555, 6666, and so on. We don't need to write the whole number anymore. And you can tell that since these numbers are all multiples of 1111, it shouldn't be too difficult to add them up. The first 3 numbers add to 356. Meanwhile, the numbers at the back you can just add the first and last number and pair them all up. There are 6 of them, so it's 3 pairs times 4444 plus 9999. So just go ahead and calculate this and calculate the one at the front and add them up. And remember that we only want the last 4 digits, so after you calculate all of this, don't give that 5-digit number that comes out, only keep the 4-digit number. And that 4-digit number, after you add everything up, is going to be 3685. Oops. And this is the last 4 digits. Okay, next up, question 8. How many distinct triples of positive integers a, b, c satisfy 1 less than or equal to a, less than or equal to b, less than or equal to c, and 1 over a plus 1 over b plus 1 over c equals to 1? At first glance, this does not look like enough information. Because how are you supposed to solve for a, b, and c? 3 different unknowns using only one equation. Indeed, it would usually be not enough, but here they tell you that these are positive integers, and of course they are positive integers in ascending order. So if they are positive integers, then there are not actually as many ways as you might initially think. Now the reason for that is that if your a, b, and c are in increasing order, that means that the 3 fractions, 1 over a, 1 over b, 1 over c, are in the other order. The reciprocals are decreasing. So you have 3 things adding up to 1. Now if you have 3 things adding to 1, and then this is the largest one, 1 over a, that means that it must have at least been 1/3. So 1 over a has to be at least 1/3. And if 1 over a is at least 1/3, it just means that a is 1, 2, or 3. So that has already reduced your number of possibilities by quite a lot. At the same time, it is obvious that a equals to 1 does not work, because if a equals to 1, then you have 1 over 1, which already uses up your entire quota without any space for b and c. So a equals to 1 does not work at all. If a equals to 2, then you have 2 fractions that add up to the remaining 1/2. Now by the same logic again, since 1 over b is bigger than 1 over c, that means that it must be at least half of this 1/2. In other words, 1 over b would at least be 1/4. So b can be 2, 3, or 4. B can't be 2 though, because if b is 2, then again there is nothing left for c. And you would see that for 3 and 4, we do get a possible fraction. Because 1/2 minus 1/3 is 1/6. So c equals to 6 works. And then 1/2 minus 1/4 is 1/4. So c equals to 4 would work there. Finally, if a equals to 3 and a is 1/3, that means that since it's the largest one and it's only 1/3, the other 2 must also be 1/3. Otherwise, you won't have enough to make it to 1. So in total, the only 3 ways you can do it are 1/2 plus 1/3 plus 1/6, 1/2 plus 1/4 plus 1/4, and 1/3 plus 1/3 plus 1/3. Most of the other fractions are way too small for them to be combined together to give you 1. So therefore, our answer is 3. Question 9. Given 5 consecutive positive integers and the product of the largest and smallest integer is 20, 21, what is the sum of the 5 integers? Yes, if you didn't already know this, it is a very good rule of thumb to know the factorization of the year of the competition you're taking. And 2021 is 43 times 47. which happens to already be the smallest and largest of 5 consecutive positive integers. So your answer is actually instant. Well, almost instant after you add these 5 numbers up. Sum of these 5 numbers being 5 times 45, which is 225. Now some of you might protest and say, hey, I didn't know that. I should have factorized 2021, but then I thought that 2021 was some other factorization, or I didn't know how to factorize it. Well, there is another way to do this without the knowledge of the factorization. So let's say you did not know how to factorize it. We can solve this then using algebra, but when we use algebra, we try our best to pick useful variables. Now, do not call this A, B, C, D, E, and maybe do not even use A plus 1, A plus 2, A plus 3, A plus 4. Because when we have 5 numbers, it helps when we try to centralize it. So I'm going to use the numbers x minus 2, x minus 1, x plus 1, and x plus 2. So the product of the largest and smallest is x minus 2, x plus 2 equals to 2021. And once again, for the, I think, third or fourth time today already, we use the difference of squares. So x squared is 2025. And hey, you should recognize that number because we had to estimate it for question 5. So you know that x is 45, and the same conclusion follows. Okay, so once again, if you knew the factorization, no need to do this, but if you did not know the factorization, then you could still have solved it using a little bit of algebra. Okay, finally for this section, question 10. The numbers from 1 to 2021 are concatenated from left to right, and the result is read as an integer 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1, 1, 2, 1, 3, and so on until 2019, 2020, 2021. What is the remainder when this number is divided by 6? So, how do we do that? Well, the remainder when this number is divided by 6, 6 is just 2 times 3. Oopsies, looks like my 3 got slightly truncated. Let's try again. 2 times 3. The remainder when this is divided by 2 is certainly not the issue because it's odd. So the issue that we have is the remainder when it's divided by 3. Perhaps you know that the digit sum is the divisibility test when dividing by 3. Add up all the numbers. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 1 plus 0 plus 1 plus 1 and so on, and then you divide that by 3. But I think that's not going to be very pleasant because the digits are going to be a bit hard to group. It can be done, but there is actually a faster way to handle such a number. And the way to handle it is to use a little bit of modular arithmetic. There was a similar question last year as well, and I think a few years back. So we use modular arithmetic for this. And how do we use modular arithmetic? It basically allows you to combine the numbers in a more convenient way than actually just summing up the digits. Now here's how we do it. And modular arithmetic, here we're going to do it modulo 3. Meaning that we want to only care about the remainders when numbers are divided by 3. So let's call this a ginormous number x so that I don't have to write it down again. Now this big number x can be split up in this following way. It is 1 times some big power of 10. I'll leave it as a box because I don't want to calculate how many digits are behind that 1. And then 2 times another big power of 10. And this big power of 10 refers to the place value, although I don't want to count what place it actually is. And then 3 times 10 to the power of something, and so on. Of course, we will have 9. And then I'm not going to split it by digit. I'm going to continue writing it as 10 times some power of 10. The 10 is here. And then 11 times some power of 10. And then the next one, 12 times some power of 10. And so on until right at the back. So we split it not by digit, but we split it up by whatever number it is that was concatenated, which is 1 to 2021. So the last one, 2020, would be times 10 to the power of 4 because it's 4 places. So let's just put one number down there as an indication that the things in boxes are actual numbers but we don't need to find them. Now when you take modulo 3, the key thing is that 10 divided by 3 has a remainder of 1. In other words, 10 is congruent to 1 modulo 3. So in all of these, you can replace the 10 by 1. And so all the 10s become 1s. And 1 to the power of anything is still 1. So even though I don't know what's in the boxes, I don't really need to care because the outcome is always 1. So we are good. Now summing from 1 to 2021, we know that the sum from 1 to 2021 is 2021 times 2022 over 2, which is 2021 times 1011. But hey, we don't need to multiply this anymore because 1011 is a multiple of 3. So this is really nice because it tells you that x is actually divisible by 3 without us having to actually add up the digits at any point in time. Okay, so we now know that x is divisible by 3 and the number when divided by 2 has a remainder of 1 because it's odd. So it's a divisor. So the only way that this can happen is that when divided by 6, the remainder is 3 itself. Because when divided by 6, the remainder is 3, means that it's a multiple of 3 but still odd. Alright, so we have reached question 10. At this point, I guess we can take a 5-minute break of sorts. So during this time, if you want to ask any questions in the chat, you can. If you want to just discuss the paper a little bit, you can, or just get a quick toilet break before we carry on. I'm going to take a quick toilet break myself, and then when we are back, we'll look at maybe the next eight or nine questions before we take another break, maybe 45 minutes or so from now. Okay, so I think we can continue now. Now for anyone that is just joining in or just joined in about maybe like in the last 20 or 30 minutes, this entire video will be up on YouTube after the session, so you can also watch back any parts that you miss. So in particular, if any of you are taking the SMO Open tomorrow morning and sometime after 8 plus you say that you want to stop thinking about math for a while, then that's okay. And if you're curious about anything, you can always come back and watch the recording. I also see that the chat is extremely well behaved to the point of total silence. So what I would just add my 2 cents about the paper this year is that it is certainly a bit more difficult than the previous years. However, whether that will translate to all the cutoffs moving or just some of them really depends. So for example, if let's say there are 5 really difficult questions. Now those 5 really difficult questions, almost nobody will solve them. So it doesn't really affect, let's say, whether you get an honorable mention or a bronze, because those 5 questions, a really small number of people would solve anyway. So even if those last 5 are really difficult, it doesn't quite make a huge difference. So I do think that maybe it will get lowered a little bit, but as to concrete scores, I wouldn't want to say for sure what is a bronze, what's a silver, what's a gold, what's anything for that matter. Okay, so let's carry on for the next few questions, starting with 11. So in this sum, every letter represents a different digit, and they tell you helpfully that S is 6 and E is 8. Now I have to actually say that you don't need to know this. Without even a 6 and 8, there is enough information to solve this. But it will be a lot slower. You will need to do a lot more trial and error. So by telling you S is 6 and E is 8, this will make things quite a lot simpler. So let's rewrite this below with S being 6 and E being 8. Now, as always, for these kinds of alphametics, what you want to do is to just add up in different place values and see what information it tells you. Now, the easiest of them is to look at this leftmost digit. So 68,000 and something, 68,000 and something, 600 and something. The total would definitely be 100,000 and something. So T definitely is 1. Now at the same time, if we look at this 8 and 8 in the thousands place, 8 plus 8 is 16. But we have an 8 below, which tells you 2 things. First of all, it means that there must be a carryover of 2 from the hundreds place. And it also means that 8 plus 8 plus 2 is 18. There's a carryover of 1 into the 10,000s place. And so therefore, W, if you have 6 plus 6 plus 1 is 13. So that means that W is 3. Now if you focus on the hundreds place next, you've got V plus 6 plus whatever carryover gives you N, and then a further carryover of 2. That means that V has to be pretty big, because V has to be pretty big in order to get a carryover of 2. If you focus on the tens place, 8 plus something gives you 1. I mean 16 plus something gives you 1. You know that the only way to get that would be 21. So there's also going to be a carryover of 2 down here. based on this hundreds place now, it means that 2 plus v plus v plus 6. So 8 plus 2v give you n with a carryover of 2. And remember that you also cannot repeat any digits because you have already used up 6 and 8 and 1 and 3. So rather quickly, you can come to the conclusion that the only one that would give you valid solutions would be v is 7 and n is 2. Now, all the other numbers are already used, and if you use v equals to 9, then n equals to 6, which also is already used. So that gives you a couple more numbers. V is 7, n is 2, and this n also comes here. Now, so far we have used 1, 2, 3, 6, 7, and 8, which means that we're only left with 4, 5, 9, and 0. Now, there are two possibilities then, in terms of how you can make your x and y. Either your x can be 5 and y is 9, or if x is 0, then y is 4. But in both of these cases, there's no carryover, which means that 8 plus 8, to give you 1, I must have been 5. So if I is 5, then it eliminates the one that used 5. So therefore x must be 0 and y must be 4. And so having worked all of this out, the number 6, SIX, is actually 650. Now, I didn't really write down the steps very carefully because this is something that you do with a lot of intuition. Sometimes you will go to the left and see, can I do something here? Oops, I'm stuck. Okay, let me move to the right. Can I do something here? And you're just really moving around. And every time when you can find something new, you see whether it affects the thing on the left and right. So you don't have to do it in the order that I did. I think there are a couple of other orderings that you could have done. The most important thing is don't start with guess and check. If towards the end, you do a bit of guessing, that's okay. But if you guess right at the start, it's going to be really frustrating because you guess 1, you try the whole working, it doesn't work. Then you try 2, you do the whole set of steps, doesn't work again, and you have wasted lots more time than necessary. So leave any guessing you do right to the very end. Okay, next up, question 12. What is the value of square root 219 times 220 times 221 times 222 plus 1? Again, for this question, I'm going to give two different approaches. One is the so-called Smo Friendly Method, where you just need to find some pattern. And then I will show the algebraic approach right after that. So what's the pattern that we can form on the left? Well, we see there are 4 consecutive numbers. You multiply them, you add 1, and then you square root it. So let's try that for smaller numbers. If we do 0, 1, 2, 3, multiply them plus 1, obviously this gives you 1. If we do 1 times 2 times 3 times 4 plus 1, this is 24 plus 1, 25, 5. Let's do at least 2 more to find out what pattern we can get. So 2 times 3 times 4 times 5 is 120, plus 121 square rooted is 11. And perhaps one more, 3, 4, 5, 6, and then plus 1. Now, this would be square root of 361, which is 19. Now perhaps then some of you, if you saw this kind of pattern, your instinct is to say, alright, then I plus 4, plus 6, plus 8, and so each time the difference increases by 2. Certainly there is nothing wrong with this, but we can do a little better in terms of expediting our work by observing that, let's say 5 is just 2 times 3 minus 1, 11 is 3 times 4 minus 1, 19 is 4 times 5 minus 1, and of course the one on top is 1 times 2 minus 1. So this tells us that our pattern should be the two middle numbers multiplied together minus 1. So we can certainly take 220 times 221 minus 1 and be fairly sure that this is going to give you the correct answer. Okay, so that's the pattern finding way, which is perhaps friendly to the SMO if you do not know how you should go about simplifying something like this. Now, let's show the more algebraically rigorous approach. And instead of 219, 220, 221, 222, I'm going to let x be 219. So this in the square root would be x plus 1, x plus 2, x plus 3, and then whole thing plus 1. Now we don't want to expand all of this and get a huge mess. That sounds like a really bad idea. But what we can do is actually to pair them up like this. If you pair them up, x plus 3 gives you x squared plus 3x. X plus 1, x plus 2 gives you x squared plus 3x plus 2, and then this product you plus 1. Now notice that x squared plus 3x and x squared plus 3x plus 2 are just differing by 2. So we can do another substitution and let y equals to x squared plus 3x plus 1. So that what we're left with is y minus 1, y plus 1, and then plus 1, whole thing square rooted. So this is equal to the square root of y squared, which is y, and then you would need to substitute it back in. So y is x squared plus 3x plus 1, where x is 290. Now if you do that computation, you would realize it gives you the same thing, because this is really just x plus 1, x plus 2, minus 1. So that's actually not inconsistent with our pattern. In fact, it explains why the pattern works, this being the special case of this. Okay, either way you should still get the same numerical answer, which I would just put down here. Okay, question 13. This is quite a fun question. A to I are unknowns satisfying the following sums, and it's the sum of so-called 3 consecutive letters is 1, 2, 3, 4, 5, 6, 7 respectively. And we are asked to find what is the value of A plus E plus I. Now I'm going to just write down A, B, C, D, E, F, G, H, I in a row. And then we can look at the 3 numbers that they asked us for, which is A, E, and I. Now, A, E, and I is not one of the sums that we are given, but we can look at what is not included. Now what is not included is BCD and FGH. And BCD and FGH are included in our sums over here and over here. So that means that we can just find the total and minus off those two green boxed sums. In turn, to find the total of everything, we can split it this way: ABC, DEF, and GHI, which are also given down here. So that means that to find the sum A plus E plus I, all you need to do is to take 1 plus 4 plus 7 and minus off 2 and 6. So this, of course, would give you a number 4 as your answer. So you know that you can't always solve for the unknowns when there are not enough equations. There are 7 equations for 9 unknowns. So 7 equations for 9 unknowns is usually not enough to actually find out what A, B, C, D, E, F, G, H, I all are. It's only enough information to find out some things about them. And so whatever it is that they ask you for, don't think that you need to find A, E, and I. It may be something like this, where you just combine the information in some clever way. Next up, question 14. X is a 3-digit number, and we define capital M of X and little m of X respectively as the largest and smallest positive number that can be formed by rearranging the 3 digits of X. So for example, if X is 1, 2, 3, then the maximum you can make is 3, 2, 1, and the minimum is 1, 2, 3 itself. So if Y is 8, 9, 8, then the largest is 9, 8, 8, and the smallest is 8, 8, 9. Given that Z is a 3-digit number that satisfies Z equals to MZ, capital MZ minus little m of Z, what is the value of Z? Now take note, of course, that it's the same Z that appears here. It's not that the Z on the left hand side is a different Z from the right hand side. We need to narrow down our search for Z. So to narrow down the search for Z, we should look at the right hand side and see, is there anything interesting about capital M of Z minus little m of Z? But at the same time, if I just refer to Z, then capital M and little m are quite inconvenient. So I'm going to write it like this. So let Z have digits A, B, and C. And A, B, and C, not necessarily in that order. I just want it to be such that A is the largest, and B is the next largest, and C is the smallest. So that means that I don't actually know Z, because it may be ABC, it may be ACB, it may be BAC, and so on. But the largest you can get is ABC, while the smallest you can get is CBA. And here when I write ABC and CBA, I mean the 3-digit numbers, not the multiplication. Even so, when you write the difference, it is probably a bit more useful if you look at ABC as 100A plus 10B plus C, and the little m of Z can be seen as 100C plus 10B plus A. The difference between the two if you take big M of z minus little m of z, the 10b will cancel off, so this is actually 99a minus 99c. And this is really great because it tells you that your number is a multiple of 99. Because remember, this is z. So z is a multiple of 99, and is 99 times the difference between the largest and smallest digit. Now, if you look at the multiples of 99, the multiples of 99 follow a very simple pattern. 99, then 198, 297, 396, 495, 594, and so on. The last few, I have no space and no need to write. It ends at 990. Now you see that the one in the middle is always 9. So that will always be A. The largest digit is always going to be 9. So this A will always be 9. And so it just becomes 9 minus the smaller digit times 99 has to be the number itself. So we can go down this list and check the value of A minus C, and just by observation. So by observation, the one that works is 495. And the reason 495 works is that the difference between 4 and 9 is 5. So the A minus C in this case is 9 minus 4, which is 5. And this is also 5 times 99, so that's exactly what we wanted. And so frankly, the main thing here is that if you knew this property, that a number reversed and you take the difference, gives you a multiple of 99, then that's the key to this question, so that your z cannot just be any 3-digit number, but only somewhere in this list of multiples of 99. Okay, next up, question 15. How many integers k are there such that this quadratic equation, kx squared plus 20x plus 20 minus k equals to 0 only has integer solutions? Now this one is probably not so straightforward because we might not know where to look. Whenever you encounter such a question, then you should try to see, is there anything suspicious about this? And I think it is quite suspicious that k appears twice. In the x squared term and in the constant term, and 20 also appears twice. Right? That's a little bit suspicious. So it's a little bit suspicious, meaning that in a perfect world, you kind of want the 20 to cancel off and the k to cancel off. And so you can observe, based on this, that x equals to minus 1 will make it cancel off. So if x equals to minus 1, the 20 cancels out, and the k and k also cancels out. So minus 1 is definitely a solution, no matter what k is. Minus 1 is always a solution. So actually, this is a quadratic equation, right? So for the quadratic equation, we expect at most 2 solutions. if one of them is minus 1, then we only need to make sure that the other solution is also an integer. So how do we check that? Well, we can actually make use of the fact that the sum of roots in our quadratic equation, so the sum of the roots of the quadratic is minus 20 over k. So if the sum of roots is minus 20 over k and minus 1 is a solution, you just need to make sure that this sum is also an integer, and then the other one will naturally be an integer too. So this here must be integer. So this must be integer, meaning that k is a factor of 20. If k is a factor of 20, then 20 is small enough, I guess. We can just list the factors of 20. And remember also that k can be positive or negative. So plus or minus can be placed on the outside. So k can be anywhere in this collection, either plus or minus. And each of those will give you an integer sum of roots. So if the two things sum to an integer, then that one other solution would also be an integer. So therefore, there are 12 possible values of k. So there are 12 possible values of k. I have to add a caveat that if k equals to 0, technically you only have integer solutions, but that's not a quadratic equation anymore. So to me, I would think that k equals to 0 should not be included. But of course, if you included k equals to 0, there's every chance that that answer may be considered as acceptable in retrospect as well. Next up, we get a geometry question with another circle, and AB equals to BC equals to 6, AD equals to 14, and CD is the diameter. CD is the diameter, meaning that CO and OD form a straight line, but otherwise these are all equal to the radius. We are asked to find the length of CD. Okay, so the question comes down to how are we going to make use of both the 6 and 14? There are a couple of ways that we can approach this, but what I think would be most useful here is to actually use just Pythagoras Theorem in the following way. I'm going to draw the height over here. I don't know what this height is, but I know that you will divide AD evenly into 7 and 7. Let's call this height h. Now for those lengths, 7 and h, I can also bring them down here by drawing another right angle. I'll call this length h again, and this is 7. We also have to make use of the fact that we are working with the same radius throughout. So let's call the radius r, and then this length down here would be r minus 7. Now using Pythagoras Theorem, we can apply it to two different right-angled triangles. Firstly, 7 squared plus h squared equals to r squared. Secondly, r minus 7 squared plus h squared equals to 6 squared. So the first one is the big right-angled triangle, and the second is the smaller right-angled triangle. Now all we want to do is actually to find the radius. So since we want to find the radius, I'm going to subtract the equations. Now by subtracting the equations, what you get is you cancel off h squared. And cancelling off h squared is going to just give you a quadratic equation in terms of r. So if you simplify this, the 7 squared will cancel off on the left. So minus r squared plus 14r equals to r squared minus 36. And you solve this, it would give you r equals to 9. And if r equals to 9, then the length of CD is 2 times of that. Especially as we get to the more difficult questions, we are going to slowly take away the discussion of solving this equation, and then I'll just focus on the key ideas so that it will be a bit faster. Once you understand the idea, feel free to work out the algebraic details on your own in case you didn't manage to solve the problem during the competition. Okay, next up, question 17. So the diagram below shows a piece of cardboard in the shape of an equilateral triangle. This equilateral triangle has side length 36, and then the length of these cuts are 2 square root 3. So then you get to fold it up into a kind of a tray, they call it, such that the base is a smaller equilateral triangle and the height is 2 square root 3. So what's the volume of this tray in cm cubed? Well, we know that the volume of the tray is just the base area times height. The base area is this equilateral triangle over here, and the height is 2 square root 3. Now there's something about equilateral triangles which is, I guess, pretty important and certainly needful for this question. So what you need to know about equilateral triangles is that if you slice them into two, oops, let's try that again. If you slice it into two, these will be in the ratio 1:2. And using Pythagoras Theorem, it means that these right-angled triangles would be 30, 60, 90 triangles with height square root 3. So the ratio is 1:3 2. We're going to use this throughout the whole question because everything in this figure has to do with equilateral triangles. So if we specifically look at this right-angled triangle, then these are the ratios that we will use. Of course, if you have done any trigonometry, you would know that these are just sine 30 degrees and cosine 30 degrees that we are making use of over here. But these ratios can be found without using any trigonometry at all. So coming back to our question, we need to find out what is the base area. To find the base area, we would really like to find the base and height of this equilateral triangle, namely this base over here and this height over here. So how do we find that base? Well, to find the base, you would want to take the total length, which is 36 cm, and subtract off those little dotted lines at the left and right. Over here and over here. Now, how do we find the length of one of those? Well, these triangles here are precisely in the same ratio as what we have shown on the right. These are 30, 60, 90 degree triangles. So they are exactly in that ratio. And so this length is going to be in the ratio square root 3 is to 1 with the height 2 root 3. So 2 root 3 times square root 3 again, which is equal to 6. So that means that by symmetry, this is also 6. And therefore, this base here is just 36 minus 6 minus 6 is 24. So that's the length of one side of the equilateral triangle. Now, if we want to find the height of the equilateral triangle, we can use this same idea again. Because when I split it up like this, the 24 is split into 12 and 12. And the height is going to be square root 3 times of that. So 12 square root 3 is the height of the equilateral triangle. So therefore, we have found the base and height. So the area of the triangle is half times 24 times 12 square root 3. Not forgetting the 2 square root 3 from the height. So doing some multiplication, and if we simplify this appropriately, the square root 3's will become just a factor of 3. So no more square roots are in your final answer. Okay, next up, question 18. What is the value of the floor of the square root of 45 plus square root 2021 minus the square root of 45 minus the square root of 2021? This bracket, in case you're not familiar with it, is the floor function. And all it means is just to round down. For example, if your answer is 15.3, then you should round it down to 15. If it's 15.9, still round it down to 15. So really the only reason why it's there is just to make sure that you get a whole number as your final answer. If you have seen SMO problems in the past, this shouldn't be particularly surprising. You have potentially seen this difference of square roots or sum of square roots as standalone questions in the past as well. The easiest way to do it is just to call it x. And unsurprisingly, with this huge glut of square roots that we want to get rid of, we would just want to square the whole thing. You just want to square x. And the reason why squaring x is not such a bad idea is that the two things on the inside are conjugates of one another. In other words, when you multiply them, you get something nice. So let's work it out. When we square it, the first becomes 45 plus square root 2021. And then minus 2 times of the product, and then plus the square of the second one. Now the good news is that you can see the square root 2021s around and they can be cancelled off fairly immediately. Cancel the first and last square root 2021, and for the part on the inside, since we are taking the product, it would be 45 squared minus 2021, and this would be, I think, the third time we have seen 45 squared today, so we know that's 2025, the difference is just 4. So 45 plus 45 minus 2 square root 4 is 86. So x is the square root of 86, and the square root of 86 is somewhere between 9 and 10. 9 point something, and the floor of x is 9. Okay, now we have reached question 19. For this problem, if you have a better method than what I'm going to suggest, please feel free to type it into the chat, because unfortunately I wasn't able to think of a very nice looking solution for this problem. Okay, so the first thing that we notice is that just like in question 18 actually, the things inside the square roots are almost the same, except that there is a minus and a plus. So which means that we can just square the whole thing. Now this will not work out quite as nice as question 18, but since we see that the final answer is asking you for something about x squared, we're not too shocked that our working has to involve squaring the whole thing, and you're not going to see much of x at the end of your working. It will all be x squared and x squared squared, as we will shortly see. So I'm going to square both sides, and we're going to do this quite carefully. So we square both sides. The first square just clears the square root. I'm going to write the second square down next to it first, because that's nicer. And then the middle term is 2 times of the square root of their product. Now, how am I going to group them? I'm going to write it actually as x squared plus 5 minus 4x. And x squared plus 5 plus 4x, so that we can use our difference of squares for now what would be the, I don't know, 7th or 8th time already. And the square of 3x is 9x squared. I'm going to move everything to the right side except for the square root. For the square root, it would be the difference of squares. So x squared plus 5 squared minus 4x squared. And everything else that I move to the left, after subtracting off, you would get 7x squared minus 10. So the reason why this is not entirely absurd is that everything on the left only involves x squared, and so does the right. There is no x or x cubed. It's only going to be x squared and x to the power of 4, which means that whatever we get at the end is just going to involve some even powers of x. If you're not quite sure what that means, let's continue working this out. The term inside the bracket we can simplify as x to the power of 4 minus 6x squared plus 25. So if we square again, so we square one more time, 2 squared is 4, otherwise is 4 times of what's inside the square root. On the right side, if we were to square it, it is 49x squared minus 140x squared plus 100. Now this would normally be pretty unpleasant, but one skill in Olympiad math is to pick up any nice things happening. And so something nice is actually that the 4 times 25 is 100, so it's going to cancel out, and we don't actually need to solve anything that complicated as it turns out. So 4x to the power of 4 minus 24x squared equals to 49x to the power of 4 minus 140x squared, with the hundreds being gone. So we can move everything over to the right. 45x to the 4 minus 116x squared. And because x is obviously not 0, since positive is mentioned, x can't be 0. That means that you can divide by x squared and you conclude x squared is 116 over 45. Now what you're asked to find is the floor of 10 to the power of 4 times this, which means that you just really have to multiply by 10,000 and write it as a mixed fraction, which I shall just give the numerical value at the end. So I'm seeing a suggestion in the chat that we can also have used the conjugate to multiply to both sides. I think that is a possible approach that will make it slightly easier. However, I don't see any way that we can avoid at least squaring it once. So this is unfortunately something that we have to do at some point of the working, unless someone has an alternative suggestion they would like to share. Okay, so we have 6 more questions, which actually aren't the most difficult necessarily, but I think it's a good time to just take another 5 minutes break before we wrap up at the end. Okay, so for the last step, why we end at x squared is because the final answer is only asking us for something times x squared. So there's no need to actually solve for x and write the square root down. We just divide both sides by x squared, and then it will give you x squared is 116/45. Okay, so we will pause for a short while before resuming again. Okay, and we are back. We will be looking at the last 6 questions in a moment. But I guess this is an appropriate time if anyone of you has stayed until this point from the very start. Thank you very much, and I'm glad you have been patient enough for the last couple of hours. Sorry about any technical issues because I'm not really working on a streaming laptop. It's just a very normal laptop, and it can get a bit overloaded when trying to do a few things at the same time. So thanks for your patience, and a bit of self-promotion. Do subscribe to this channel if you enjoyed the session so far. And senior and open sessions are in the next 2 days. So if you are actually taking the SMO senior next year, or maybe you are taking the SMO open as well tomorrow, then feel free to join in the other sessions as well, or to just maybe look at those questions that you're interested in after the session is over. It's completely up to you. Okay, so let's try to wrap up by 9 o'clock. Question 20. What is the number of positive integers c such that the equation has real roots? Now when we say the equation has real roots, it just means that the equation can actually be solved. There is such an x. If you have learned the discriminant, you would know how to do this very fast. But I'm going to operate under the assumption that for SMO Junior, not all of you may know the discriminant. So I'm going to take it down a notch, and I'm just going to complete the square, which is technically the same thing, but it is most likely familiar to a larger number of students who are attending this stream. So when you complete the square, it will be x minus 2021 over 2 squared minus 2021 over 2 squared plus 100c equals to 0. So if we move over to the other side, which is what we normally do when we solve equations by completing the square, it is equal to 2021 over 2 squared minus 100c. So when we use completing the square, we know what's coming up next, right? You write plus or minus the square root of the right hand side. So in this case, it just means that for it to have real roots, you must be able to square root the right hand side. So this here must be greater than or equal to 0. Now the rest of it is just the mildly annoying task of dealing with 2021 squared, because the right hand side must be greater than or equal to 0. We rearrange it, it means 2021 squared is greater than or equals to 400c. So c is less than or equals to 2021 squared over 400, which I'll save you the time and just say for now that this is equal to 10211 point something. Now there are various little shortcuts that you can use to calculate 2021 squared over 400, but I believe that just for one question's sake, any method you can use to calculate and divide is worth it, since once you get this, your answer is just 10211. Yeah, so this brings us to our last 5 questions. Question 21. In chess, 2 queens are said to be attacking each other if they are positioned in the same row, column, or diagonal on a chessboard. How many ways are there to place 2 identical queens in a 4x4 chessboard such that they do not attack each other? Okay, so here's how I would do it. When we're doing any counting questions, we can always tweak the question a bit to help us, as long as we remember to adjust it back to whatever it is the question originally said. So over here, what I'll do is quite simple. I'm going to first imagine that the 2 queens are not identical. So I'm going to imagine the queens are different. There is a black queen and white queen. I'll just abbreviate as B and W for short. And I'm going to draw that 4x4 board over here. Now the reason why I want to give them a name is that I want to say, okay, I'm going to put the black queen first. So if I want to put the black queen first, then at least I have a name to refer to it as the black queen. So let's start by looking at if the black queen is placed in the corner. Now if the black queen is placed in the corner, then everything over here is considered attacked. So that means that only the 6 squares that you can see are available to the white queen. So if the black queen is in the corner, then there are 6 choices for the white queen. So I'm going to now just erase what I just wrote because we're going to use the same thing for the other 2 cases. But from what we have seen, we know that this means that there are 6 choices here. And the same thing will apply for all the corners because this figure is symmetric. Next, let's look at the edge. If let's say that the black queen is over here, now it would block out these squares. So if you count again, there are 1, 2, 3, 4, 5, 6 squares that are not attacked by the black queen. So if the black queen's at the edge, again there are 6 choices for the white queen. Now the edge is going to be symmetric again, so I'm going to label all of these ones are also 6 ways. Now finally, if the black queen was somewhere in a center square, it's going to block out a lot more actually this time. I'm going to block out everything here. So there are only 4 squares that are not attacked, the ones that I just pointed to. In other words, if the black queen is at the center, there are only 4 choices for the white queen. Okay, so that's all the cases, because it means that you can put the black queen in any square on the chessboard, and we know how many choices there are for the white queen. So the number of ways, as we can see, is 4 times 4 plus 6 times 12, which is 88. However, this was done in order so that we can name the first queen to be placed when actually the 2 queens are identical. So therefore, we need to divide by 2 to get our final answer. So if you're worried that your counting method is going to lead to you overcounting and forgetting that they're identical, perhaps the easier way is to just assume they are not identical at the very start, count it that way, and then divide back at the end of your solution, which is what I've tried to do here. Next up, question 22. Let A equals to 3 over 2 times 5 over 4 times 7 over 6 and so on until 801 over 800. What is the value of the floor of A over 10? Now let's think about this. And something we like to do in math a lot is wishful thinking. Now by wishful thinking, it means that when we cannot solve the question, we ask ourselves, is there something that would make the question really, really easy to do? So let's write down A. And so on until 801 over 800. Now what would make this really easy to solve? I think from our experience with fractions, what makes fractions easy to multiply is when certain things in the numerator and denominator cancel out. So in a perfect world, we would say that, if only it wasn't alternating, right? If only that you had 4 over 3 here, 6 over 5 here, 8 over 7, and so on, until, let's say, 802, 801. Now, this would be really nice. Now, if I could have all of these here, then everything would cancel out. Well, wishful thinking says that if what you hope for is that you can have all of these terms and multiply them, then you should take all of those terms and multiply it, and I'll call this B. It's exactly what we want to do. And notice that based on how we've written it, 3 over 2 is 1.5 is bigger than 4 over 3, which is 1 1/3. 5 over 4, which is 1 1/4, is bigger than 6 over 5, which is 1 1/5. And so every of these fractions here in B are slightly smaller than the one in A. Which means that overall, since you're multiplying all the fractions which are slightly smaller, B is less than A. But their product, because we use wishful thinking to make these extra fractions appear, A times B would be 3 over 2 times 4 over 3 times 5 over 4, and so on, because these were chosen carefully by us. Obviously, they're going to cancel out. In fact, everything cancels out except for a couple of things. 802 over 2 are the only ones that survive. So this is 401. Now what that tells us is that you multiply A by something a little bit smaller to get 401. That means that A squared would be bigger than this. So A squared is more than 401. And if A squared is bigger than 401, that means that A is more than 20. So we have managed to estimate it from one side. Now how do we estimate it from the other side? Because if A is more than 20, then how do we know A isn't 50 or 100 or 1000? Well, we can now come up with C and put C on the other direction. We can let C be 2 over 1, which is on the left of 3 over 2, 4 over 3, which is on the left of 5 over 4, and so on. And so since it's on the left, we just stop one term earlier. We stop at 800 over 799. In this case, C is definitely bigger than A. But using the same idea, AC is now 2 over 1 times 3 over 2 times 4 over 3, and so on all the way to 801 over 800. We get to do our nice cancellation thing again. And this time, we are left with 801. So you're left with 801, and this time you multiply it by something bigger. So if you multiply it by something bigger, this is more than A squared. So A squared is less than 801. We just need to say A is less than 30. Now why is that? Because for this question, it turns out the SMO question setters were pretty kind. You don't need to estimate it that well, so you don't have to know whether A is square root 801 or something like that. It's enough to say that A is between 20 and 30, because that means that A over 10 is between 2 and 3. Oops, let me. So it means that 2 is less than a over 10 is less than 3. So therefore this is equal to 2. Right, we're almost there, so keep at it. Question 23. A 3 by 3 grid is filled with the integers 1 to 9, and you call the arrangement nice if it is increasing both from left to right and top to bottom. So there are two examples in the diagram, and we are asked what is the total number of distinct nicely ordered arrangements. Now this question is admittedly not very easy to solve in a 1 or 2 line method. You can't really say, oh, it's just going to turn out to become 5 times 6 times 4. It's not going to turn out that way. And for anyone that solved it, you probably had to split up into some cases. But try to make sure that the cases you split up into are not too fine-grained. So if you split up this question into, let's say, 20 cases, then you might as well just have drawn every single possible grid. Right? You hope for something that is kind of broad enough that when we come out with one case is a big enough section of your possible arrangements. In case you have no intuition for what kind of arrangements are called nice, look at the grid. One thing that we notice is 1 and 9 are always in the corners. And that is not very difficult to tell because anything else will be bigger than it. So you can only put 1 at the corner and anything else will be smaller than 9. So 9 has to go there. Another interesting thing is the position of 2 and 8. 2 and 8 have to be somewhere next to the 1 and the 9 respectively, because the only thing smaller than 2 is 1 and the only thing larger than 8 is 9. So there's really no choice. 2 and 8 either have to be placed like that or like that. Now when I say like that, this is the case where 2 and 8 are opposite each other. And this is the case where 2 is diagonally adjacent to 8. So 2 is kind of adjacent to 8. Now there are actually two ways that 2 and 8 can be opposite. It could be at the top and bottom as well. There are also two ways that 2 and 8 could be diagonally adjacent. They could be over here as well. So I'm going to then just note down that when they're opposite and adjacent, there are two different ways this can happen. Both for here and for here. So let's consider each of these. And I'm going to redraw the grid again so that we can analyze them both separately for how many arrangements there will be. I'll start with the one on the right because it turns out to be a little bit easier. If you put 1, 2, 8 and 9, notice that this number in the corner can be anything. There are 5 choices for that. 3, 4, 5, 6, 7, all okay. For the rest of the 4 squares, you notice that this will be the smallest one. So after you have placed that corner, this is the smallest of the remaining, and this is the largest of the remaining. As for the other two, you can do whatever you like with them. So that means that we get 2 more choices, let's say for this one, for these 2 remaining squares. So that means that our second case can be summarized as 2 times 5 times 2, which is 20 ways. Okay, I think I can leverage technology a bit better than I've been doing, such as just shifting this all a little bit to the right so that I can have more space for my first case. Now for the first case, we do unfortunately need to subdivide just a little more. So you have 1, 2, 8, 9. Let's draw that out in a separate diagram again. Now there are a couple of choices again that we would have to subdivide the remaining grid into. I'm going to split further into where I put the number 3. Now the number 3 can either go into this position or into this position. There are two ways. So if let's say you put the number 3 down here. If you put the number 3 down here, it becomes almost exactly the same as the one on the left. Sorry, the one on the right. Right? Because if you put 3 down here, once again you can do anything here. You have got 4 choices. And then this is the largest, so that would be fixed. And then you have 2 choices for the rest. On the other hand, if you place 3 at the bottom left corner, then for this corner, the top right corner, you can't put the number 4 there. 4 has to be down here. But then you can put anything you like down there. 5, 6 or 7 are okay, and the other 2 would be just the smaller one goes in the center. So you have 3 choices in this case. So 2 times 4 plus 3 times 2 is 22. Right, so there are 22 cases for this left configuration. There are 20 cases for the right configuration. So overall, there are 42 different arrangements. Now, if anyone has a nicer explanation for this as well, I will welcome it. This seemed to be the least amount of casework that I could do by looking for a choice that was kind of very non-interfering. So for example, in the right side, when you put the top right corner, you can put anything there and you would still have 4 choices for the rest. Right? So I tried to do something similar for the other 2 cases, but if you can think of a better way to subdivide them, certainly I would be happy to hear of it as well. And then you come to question 24, which is definitely a huge drop-off in difficulty, to the extent where you almost might not have noticed the question if you're doing it in order. So this is a very welcome reminder that you should look at all of the possible questions from 1 to 25, even if the ones at the back look really difficult. So he says that a class has exactly 50 students, and it is known that 40 students got A in English, 45 scored A in Math, and 42 scored A in Science. What's the minimum number of students who scored A in all 3 subjects? Now, the minimum number of students who scored A in all 3 subjects, this will be obtained if you have the maximum number who did not get an A in some subject. So the maximum who missed an A. Now for English, there are 50 students, 40 A, so which means that there are 10 students who missed an A. For math, there are 5 students who missed an A. And for science, there are 8 students who missed an A. So these are the ones that missed an A. And we know that if these are the ones that missed the A, the maximum possible that could have missed is if all these 10, 5, and 8 come from 3 different groups that have no intersection. So the maximum that could have happened here is the sum, which is 23. So at most 23 students would have missed an A. And so therefore the minimum number who did get an A is 50 minus 23. Equals to 27. So that was nice and simple to compensate for the bit of casework we had to do for question 23. Finally, question 25. And once again, I would be interested to know if there is a very clean solution for this. But I think there are quite a lot of practical observations we can make down here. So it says here, suppose a positive integer x satisfies this equation, the fifth root of x plus 76638 minus the fifth root of x minus 76637 equals to 5. What is the value of x? Now in general, and I'm not going to try to prove this, but in general, if you try to take the nth root, now the nth root, normally for most questions you've seen so far, it is square root, or if they are being particularly obnoxious, cube root. But this is the last question, so hey, they decided to make it harder with a fifth root. In general, if you have integers a, b, and you take the difference of their nth roots, and you get another integer, the only way that this can happen is when a and b are nth powers. In other words, both of those roots are actually integers themselves. So both of these should be integers. In other words, x plus 76638 should be some fifth power, and x minus 76637 should be another fifth power. Of course, there are two fifth powers where the difference between the a and b is 5. So based on this, we can conclude a couple of things. We know that a minus b, which is the difference, is 5. And we also know that if we subtract off, we will eliminate x and just get a difference of fifth powers, which is the most pleasant thing in the world, but it is probably the best we can do. Now, at this point, what I'm doing is probably a bit more practical than really very elegant, but I will look at, okay, 5, right? Basically, a is, this whole thing now is called a, and this whole thing here is called b. So this is a minus b equals to 5, because I called the thing inside a to the power of 5 and the thing inside on the right b to the power of 5. Now I'm trying to use these two equations here to obtain, well, a and b. With the knowledge that a and b should be integers. Okay, I think part of the confusion is that what I wrote down here at the top is not the same a and b, that is a general statement. Right? So I shall probably box it up and say this is a general statement, this is not for this question only. I'm making a general assertion. So based on these two equations, you want to get some idea of how big A and B should be. Meaning that how many fifth powers am I supposed to actually calculate? And so one way that you can do it is to actually factorize A to the 5 minus B to the 5. Now, I'm not going to use the binomial theorem in case some of you have not learned it before. If you knew the binomial theorem, you could substitute A equals to B plus 5 into this equation, and that may actually be a bit nicer. I'm going to not touch the binomial theorem. I'm just going to factorize like this. And this is your 6-digit number 153275. This is 5. So if you do a quick division, this would be 30645. Now there are some other factorizations which you can actually do over here. But I'm going to just take a practical approach again and say that we can get a pretty good idea of how big A and B actually are based on this second bracket over here. And the reason for that statement is that if A to the 5 minus B to the 5 is positive, of course it means that A is greater than B, which means that this entire expression here would be greater than B to the power of 4 times 5, because all of these individual summands are more than B to the power of 4. So 30645 is more than B to the 4 times 5. So therefore B to the 4 is actually less than 30645 over 5, which is 6129. If this doesn't sound very impressive, the good news is that this already is quite constraining. It tells you that B is between 1 and 8. At the same time, you know that A to the power of 5 has to be more than this. So you also get an idea of how big A has to be. A to the power of 5 has to be more than 153275. And 10 to the power of 5 is only 100,000. So you know that A has to be at least 11. And if A is at least 11, then B is at least 6. So if you have this bound, then it really squeezes it quite tightly, and you only have to check B is 6, 7 or 8. Now, just to shortcut all of this, if you reduce it to these three cases and check, you would find that B equals to 6 and A equals to 11 will be the two magic numbers that work. And so B equals to 6 means that X is equal to 76637 plus 6 to the power of 5. My pen is increasingly not listening to me by the end of the day, so clearly it's about time for us to conclude. And if you compute this, you get 84413. It's not exactly very exciting, but it does reduce your amount of cases down to 3. Basically, B has to be quite small, but A can't be too small, so that narrows down your search a lot. Okay, and that brings us to the end of this 2021 paper, which was probably now what feels like a long time ago, even though you just looked at it this morning. Now, before we end off this session, does anyone have any questions or suggestions that you want to make? Regardless, I hope this is somewhat useful, because maybe some of the questions you really would have had no chance of figuring out because you didn't know a particular result or a particular theorem. But for quite a lot of other questions, I think maybe you would have seen that actually you could have done it using algebra, you could have done it by finding a pattern, you could have done it by recognizing something suspicious, or a whole variety of different mathematical heuristics. Alright, so I guess it should be a good time to wrap up. Again, a couple of things. If you are doing the SMO open tomorrow, all the best. Okay, last note on question 25, right? How to check b equals to 6, 7, or 8. I'm sorry, I really do not have a better suggestion than to calculate 6 to the power of 5, because 6 to the power of 5 and 11 to the power of 5 are not too bad. You would be pretty happy to know that 6 does work, so we don't have to go down that far. Yeah, and I guess if you have any suggestions after this for a better method, you can always write it in the comments below, because this will still remain up for future viewing. Okay. I also see that Dr. Lee Chan Lai is in the chat. He was my teacher some years ago, and it's nice to see that he's here as well. Okay, so thanks everyone. Have a good night, and hopefully see some of you guys around again soon. Now I'll leave the chat up for a while, so I'm going to go off camera, but if any of you want to discuss for a short while here, I'll leave the chat active maybe for 10 minutes or so.